I'm Susan Nash, AAPG. Happy to welcome you to Pivoting New Revenue and Diversification Strategies. This is week 17, Critical Minerals and Next Generation Batteries, part 2. So today we'll be talking to Kastle Jones of Tulsa Innovation Labs, Jesse Edmondson, U.S. Critical Minerals, Emily Hersh, DCB Group, Lithium Mining in the Future, and Avi Brenmiller, Brenmiller Energy, Thermal Energy Storage. Then we'll have a little bit of time for questions and answers. So anyway, I want to thank you for being here and like to welcome our first presenter. I'd like to welcome Kastle. If you'd like to share your screen, we can get started.
Hi, yeah, thank you, Susan. I appreciate it. Let me try to share my screen here.
Okay.
Oh,
that looks great.
Can everyone see that?
Yes.
Can you see that, Susan? Thanks. Okay, perfect. All right, let's get started. So I'm Kastle Jones. I'm a senior associate at Tulsa Innovation Labs, and I'm leading the development of Tulsa Innovation Labs energy tech and drones portfolios. So kind of kicking off this with more of a visionary piece. Kind of will give you an overview of what Tulsa Innovation Labs is and talk about some exciting opportunities that are coming up in Tulsa.
Great. Sorry to jump in. Kastle, I think you need to go to slideshow and then go on and just start the show.
All right, let me try that.
Yeah, because it was not, just go up to slideshow and then start. Perfect. Okay, you got it.
All right. Whoops. There we go. Okay, so yeah, this is kind of kicking us off with more of a visionary piece and talking about some of the exciting stuff in energy tech that's coming up in Tulsa, but really applies to everywhere else as well. And I'll start off by saying that I'm definitely not an expert in battery tech, but that it's definitely one of the pivotal technologies that we're trying to cultivate an innovation economy around here in Tulsa. So excited to kind of walk you through this and kick us off. So first, just a little bit of a background of what Tulsa Innovation Labs is. We are a new tech-led economic and workforce development organization in Tulsa, pioneered by George Kaiser Family Foundation. And we were founded with a mission to create an economic development strategy for Tulsa. So that means kind of looking through the different industries and trying to find a tech niche for Tulsa. And then we'll be creating programs within those tech niches that we've identified, and energy tech is one of those. And I'll kind of, after I give you the whole TIL spiel, get into more of the energy tech initiatives in particular. But within each of our industries, we're looking to create programs that are going to develop local talent, support startup growth, and spur academic innovation. And we want to make sure that as we're creating these programs, we're also being mindful and trying to make them as inclusive as possible so that they can reach a wide audience. Just a little bit of background about our founding partner, GKFF. Some of you may be familiar, but it's a $4+ billion charitable foundation located in Tulsa. And GKFF is traditionally focused on combating intergenerational poverty in Tulsa, but recently realized, that to provide long-term positive economic outcomes for the community, for Tulsans, and to really attract top talent, they needed to get more serious about economic development, and in particular, seeding an innovation economy. So that was the genesis of Tulsa Innovation Labs, and they've tasked us with finding, what does that look like? What does it look like for this foundation to really get serious about economic development initiatives, and in particular in the industries that we've identified? And just to show you the principles that kind of led us to get to the energy tech initiatives that I'll tell you about in just a bit. We wanted to make sure that we were data driven. So to that end, we engaged with a large consultancy firm, McKinsey & Company, to identify what industries in particular that we should be invested in. We wanted to make sure that our investments were target, that we were looking at industries that had macroeconomic growth trajectories, that were creating jobs of the future that are protected from automation. So for example, as many of you are familiar, the energy industry is prone to losing, a large percentage of its jobs to automation. So, this is actually an opportunity for us to be the place where those technologies are created that are going to make sustainable jobs in the industry. And then, we also wanted to make sure that we had local assets that we could leverage. We wanted to align with our industry partners. You might have seen today, Williams just announced that they are, progressing on their reduction for carbon emissions. They're speeding up that timeline, anticipating a breakthrough in technologies for carbon capture and alternative fuels. We need to be kind of responsive to those local industry needs and make sure that we're plugging in, entrepreneurs and startups and a community around those ideas and trying to build off of that in Tulsa. And, as I mentioned before, we want to make sure that we're creating paths so that all the programs that we make are inclusive and diverse. So the result of that McKinsey study that I just told you about was kind of the 5 opportunity areas that surfaced to the top for us to focus on in Tulsa. And GKFF has committed an initial $50 million for us to invest in these things. And as I said before, broadly, these will be things like startup accelerators or venture funds or workforce development programs. The 5 areas we landed on were energy tech, drones, virtual health, and then 2 kind of cross-cutting enablers, which are really more of a workforce supply component, cyber and data analytics. So my role in particular is to lead the energy tech and drones initiatives for Tulsa Innovation Labs. So I'll do kind of a double click on the energy tech piece here and talk through that a little bit. So we found during our industry analysis that really there were 2 broad trends happening. And as you're probably more familiar with than I am, but just generally efficiency and sustainability. And battery tech in particular lies right at the intersection of this, right? So in terms of efficiency, we're talking about things like operational technology, which includes sensors and predictive maintenance. For example, putting them on drill bits to determine geological compositions or pipeline surveillance. And also, really important cross-cutting enabler for us is, using unmanned aircraft systems on drones to do things like detect pipelines. And it's interesting because battery technology also plays a really pivotal role there as well in figuring out, how we can have long-range autonomous drones to do things like survey pipelines. And then on the sustainability piece, we're talking about things like renewable energies, obviously, alternative fuels, pushing more towards electrification, anything that is kind of future looking for the energy industry. And, we've seen as that innovation is, paradoxically, to a certain extent, negatively correlated with oil and gas prices. So as we saw, in 2014, 2015, when the industry was starting to struggle, that was kind of the first wave of energy tech innovation. And we had kind of the first, a suite of successful startups that came out during that time. And the reason is because, you have subject matter experts flooding the market, and then you have these large corporations who need to maintain current levels of productivity, but with less employees. So we see this as kind of a really prime opportunity to position Tulsa and create assets, take advantage of these trends, to make a hub for these subject matter experts who are looking to help the energy industry diversify, and it's a prime opportunity for that right now. And when we did kind of the scan on where we can really plug in and what kind of programs we can build around that, we found that nationwide that there was a lack of early stage capital for energy tech companies. Either it's because that funding has been drying up due to the traditional funders being more strapped with cash, or just the general shift in the funding landscape. And also, there's no place for a hub of energy tech companies to kind of amalgamate and have those positive collisions. We saw that over 70% of energy technologies are outside of traditional tech hubs. So we see that in places like Silicon Valley, you have all kinds of different entrepreneurs constantly interacting with one another and creating innovative solutions. But in the energy tech space, traditionally Silicon Valley type technology has been biased against it and doesn't have quite the level of subject matter expertise. And now that we have more subject matter experts kind of floating around on the market, there's an opportunity to really take advantage of that and provide a landing pad, which would be an energy tech startup accelerator in Tulsa, and an energy innovation fund. So you can imagine maybe it's a grant program up front and a 13-week accelerator program where we try to attract in the top entrepreneurs and the best ideas in energy tech, and we land them in Tulsa, connect them to a network of corporate partners, and have accounting support, legal support, HR support, traditional accelerator support activities, and then opportunities for follow-on funding and providing that the filler for that gap, which is nationwide right now, for early stage funding for energy tech companies. And we're still in ideation phase right now, so we're in the process of putting this together, and I can give you a sense of what that timeline looks like in just a minute. But just that GKFF has challenged us to think big and try to solve critical problems and draw in the best minds to Tulsa and make sure that we're really energizing and positioning Tulsa to be a leader for this. So there's going to be a lot of opportunities in the energy tech space coming forward from Tulsa Innovation Labs. And the vision is to really just be recognized as an energy tech hub. As the wave of energy tech is coming, there's a huge push for diversification, and a lot of corporates really want to be the leaders on that. I mentioned Williams, a lot of other local companies, for example, Phillips 66 announcing they're turning their San Francisco refinery into an alternative fuels hub. There's a really big opportunity to position ourselves as a leader here, and there, places like Houston and Denver will obviously be well equipped and be making a push as well. But we want to make sure that we have kind of world-class assets, and over the next few months, we're going to be putting that together. I'll just quickly go over this, but these are just existing Tulsa Innovation Labs programs, which might give you a sense of what the programming will look like. And happy to take questions on this or any of the other of our 5 focus areas. But the 2 programs we currently have running is a software engineering academy called the Holberton School, which is a San Francisco based company that just opened its 3rd US location in Tulsa last January. And at scale, it'll graduate 500 engineers per year into Tulsa. And the plan is to try to, be the connective tissue so that we're plugging in these software engineers to the other programs. So for example, that the startups that land here will have a talent base so that the corporates, as they start adopting these new technologies, will be able to have a workforce supply there. And with the Tulsa Innovation Lab support, there are incentives built in for those graduates to stay in Tulsa. The second program we have is a TU Teammate Cyber Fellows program. Just quickly mention that it's a Ph.D. program at the University of Tulsa, which is a first of its kind partnership between the University of Tulsa and Teammate. And Teammate is a cyber venture creation firm based out of Tel Aviv and with offices in New York. The goal of that program is to really commercialize the Ph.D. cyber research out of that and create cyber companies, and also create highly skilled cyber talent. There's also, since Teammate brands themselves as cyber as opposed to cybersecurity, there are a lot of interesting things going on here with collaborations between our local energy corporates talking about doing projects like predictive maintenance for energy companies, for example. So it's interesting potential pivot there as well, and an opportunity to kind of specialize in cyber for the energy industry. So just to give you a sense of our timeline, as I mentioned, we just kind of wrapped up our industry analyses, which I gave you an overview of, and entered into an ideation phase. So everything that I've told you are, the program ideas that we have right now. Really confident with our 5 focus areas, and in the energy tech space, it's going to look something like an energy tech accelerator and a fund for early stage startups in that space. We'll start to begin that development, and by the end of this calendar year, release what our phase 1 plans are. And then the goal is that by Q2 or Q3 of next year, these programs will start to be operational. So anticipate that we'll start accepting startups in our first cohort, maybe Q3 next year. There are a lot of ways to get involved, obviously, whether it's an individual or a corporation. Across our 5 focus areas, we're going to have programs. The Energy Tech Accelerator, for example, is going to need mentors, entrepreneurs, investors. We're going to need, corporate support, all kinds of ways to plug in many different ways. Happy to connect with any of you offline and talk about a little bit more. We'll start to have more public-facing community events and maybe some digital events too, given the current state of things towards the end of this year, especially after our phase 1 program release. So definitely stay tuned for that. Our website, tulsainnovationlabs.com. This is Nick Lala is my manager, and Jennifer Hankins is our head of partnerships. My email is Kastle, Kastle, at tulsainnovationlabs.com. Definitely feel free to reach out to me, and really excited to learn more about battery tech today and connect with all of you in the future and figure out how to drive the energy industry forward. Susan, that was all I had prepared for my presentation. Happy to take questions or pass it on to the next presenter.
Great, thank you. Yes, that's good. I accidentally hit the wrong button and went to a different screen. But anyway, that was a really nice presentation, and it's really exciting to see that we have visionaries in Tulsa and thinking, not giving up even during these strange times, staying true to the vision. That's really great. So I'm really happy to introduce our next speaker, Jesse Edmondson, and he's with U.S. Critical Minerals. So welcome.
Thank you, Susan. Everybody hear me okay?
Yes.
Okay, great. Yeah, thank you. And thanks to AAPG for inviting me to participate in this event. I'm going to speak today about the challenges and opportunities for building critical mineral supply chains in the United States. Just real quick, just a plug for kind of my main 2 affiliations right now. So Critical Resources Consulting is a consulting company I founded in 2018. It provides technical and government relations support for various exploration, mining, and critical mineral related projects. U.S. Critical Minerals is a small private mineral exploration company I co-founded in 2019 with my partner, Dr. Robert Cook, which is focused on building out a portfolio of critical mineral assets in the United States, mainly focused on battery-related minerals and rare earths. And then I'm also currently serving as the chair of the Critical Minerals Committee for AAPG's Energy Mineral Division. Okay, so I just want to start with the definition of a critical mineral just to make sure that we're all on the same page. So kind of an abbreviated definition from the United States Geological Survey for critical minerals is that these are non-fuel minerals essential to the economic and national security of the United States. They're particularly vulnerable to supply chain disruptions, and they serve an essential function in the manufacturing of a product that we cannot live without. And so different governments and agencies maintain their own critical mineral list based on what is important to them and how they are vulnerable. These lists are meant to be dynamic and change over time as technology, economies, and supply chains evolve. So the graph on the right has the critical minerals list and illustrates our severe vulnerability and reliance mainly to China. Note that for 15 of these minerals, we're actually 100% dependent on imports for these materials. As you look at the list, I want to point out that these are actually mainly elements that are determined to be critical. And I'm pointing this out because what is actual critical is that we have access not necessarily to the raw materials, but to technology ready materials. This is what is in demand, and this is where our current supply chains are most vulnerable. So modern technology utilizes the very unique properties of elements or specialized compounds to work. And so we're really talking about high purity, specialty chemicals, and advanced materials when we talk about critical minerals. So there are 2 parts to solving these supply chain issues. Number 1 is mining. So the basic process of extracting the rock and the mineral and the materials into a mineral concentrate. This is typically done right at the mine site. And then the second component is the advanced material manufacturing. So this is taking the run-of-mine material that's produced at the mine site and converting it into a technology-ready material. And in order for most new critical mineral projects, particularly in the United States, to be economically competitive globally, they have to be vertically integrated, meaning that they have to do both the mining and the advanced processing component. Take a quick look at graphite as an example. This is the critical mineral that I've really worked the most with over the last 8 years. Graphite is a naturally occurring crystalline carbon. It has hundreds of uses ranging from pencils to industrial greases to foundry facings and refractories. Historically, demand for this mineral was driven primarily by the steel industry, which only required kind of a run-of-mine graphite concentrate. Modern demand for graphite is driven by its use in the anode of a lithium-ion battery, which requires graphite in the form of an ultra-high purity coated spherical graphite, a highly specialized material. So as we look at this process, which I've got laid out in the slide, so going from left to right, the process would typically start by mining the rock, in this case, a graphitic schist containing approximately 4% graphite or carbon. So the rock is excavated, it's crushed, and then the graphite is separated through a series of flotation and polishing and grinding stages, which results in producing a graphite concentrate that is now approximately 95% carbon. At this stage, the material could be sold into the traditional industrial markets after the flakes are sorted by size. And now we're looking at a material that's somewhere in the range of $500 to $1,000 a ton based on the purity and flake size. Even though the United States has not mined graphite since the end of World War II, run-of-mine flake graphite is not really in critical supply currently. It is very abundant globally. However, specialized ultra-high purity forms of graphite are in demand, and there's a need for new, reliable, and secure supplies of this high-quality material. So we would take that run-of-mine graphite concentrate and now upgrade it by purification. This is typically done using hydrofluoric acid or heat treatment. And then the purified graphite gets micronized, it gets sized, shaped, and gets a specialty coating to make it ready for the anode of a lithium-ion battery. And there's an order of magnitude difference in the selling price by upgrading this material from a concentrate to a specialty material. The qualification process for getting a new graphite supply into a lithium-ion battery is much more difficult than getting graphite qualified for the traditional industrial markets. This qualification process can take several years for lithium-ion batteries, and new customers generally won't initiate this process until you've at least have demonstration scale capability on site of your project. These critical minerals lack the spot market. Okay, so it's not like gold, silver, oil, gas, where you can at any given point understand exactly what the value of this material is. Instead, the value is based only on long-term contracts or offtake agreements with your customers based on meeting very specific technical specifications. So it's difficult to get a project financed past the exploration stage without these offtake agreements, but then the offtake agreements typically won't happen until you have that qualification scale capability. So this leads to a chicken or the egg situation. And this is not just for graphite. This is a similar process for all the other battery materials and critical minerals. This is just a quick side to help highlight the fact that at the root of all supply chains is raw materials. So when we talk about securing critical mineral supply chains, we're literally talking about all the vital sectors of a modern economy and society. So everything from national security, energy security, trade security, job security, et cetera. Going forward, I'm going to focus on several examples related to the clean energy supply chains, but I want to point out that this technology is not just green. It is superior, it is more efficient, and every day it is becoming more affordable. Lithium-ion batteries are not only vital for energy storage related to renewables like wind, solar, and electric vehicles, but they're also the preferred technology by our military. The typical soldier can have up to 15 different pieces of technology on them when they are in the field, all powered by a lithium-ion battery that currently contains battery materials sourced mainly from China. This illustration is from the Benchmark Minerals Intelligence Team, which is the leading authority on the complexities of the lithium-ion battery supply chains. This graph illustrates the flow of battery materials from the mine all the way downstream to the battery manufacturers and end users. And it clearly highlights that China currently dominates almost the entire lithium-ion battery supply chain, particularly when compared to the United States and Europe. If we just focus on the mining stage, so looking in the top left corner, and then the chemical processing stage in the top right, and then let's focus on just two minerals real quick, just as an example. We'll look at both graphite and lithium. So looking at graphite, China controls 65% of the supply of run-of-mine flake graphite. But then when you look at the conversion of that material to a battery-ready product, China currently controls approximately 100% of the global supply of battery-ready flake graphite, 100%. So now let's look at lithium. So China does actually not mine a lot of lithium domestically, although they do control mines outside of China, but they do have the advanced processing capability to convert mined lithium concentrate into battery-ready lithium, both lithium carbonate and lithium hydroxide. So having this conversion capability allows them to control almost 60% of the lithium supply chain as the advanced material state ready for battery use. So having the mines is helpful, but is somewhat useless from a supply security standpoint without having the advanced manufacturing capability to convert the mine material to a technology ready. So why do we not have new critical mineral supply chains being built in the United States? And I'm going to, for the sake of time, I'm going to kind of skip through this quickly, but it's just important to remember that in the case of critical minerals in the United States, you know, we have the minerals, we have money, we're a rich nation, the demand is here, and we've got some of the best infrastructure on the planet. So we can certainly justify building out these supply chains based on those factors. This map from the United States Geological Survey illustrates the fact that we do have many opportunities to mine critical minerals in the United States. And not only that, in many cases, we actually have options. So again, looking at lithium real quick as an example, it can be found in many forms in the United States. So looking at the Western United States, there are lithium brine deposits, similar to those found in the lithium triangle of South America, and also lithium clays. Then looking at the Southeastern United States, there's a well-known and past-producing hard rock lithium or spodumene district in Western North Carolina. And in Arkansas, there's lithium associated with existing bromine brine production. So now just zooming into the Southeastern United States, which actually has enormous potential to build a regional vertically integrated supply chain for the electric vehicles market. So the Appalachians are mineral rich. This map shows potential suppliers of raw materials in blue. So the cluster of companies in North Carolina are developing either hard rock lithium assets or lithium processing technology. And then Chemours, which is the blue icon in Florida, Georgia, they have heavy mineral sands operations that is now producing a monazite byproduct that could be further processed into rare earth magnets for EV motors. And then, as I mentioned, Standard Lithium in Arkansas is developing a very promising lithium project where they can directly extract lithium from the waste stream of an existing bromine operation. So we have the minerals. The battery manufacturers have also started to show up to this region. They're shown in red. So we've got Envision, which is up in Tennessee. And then most notably and recently is SK Innovation's announcement to build a major lithium-ion battery plant just outside of Atlanta, Georgia. You know, over $1 billion investment, thousands of jobs. Alabama is now actually one of the top manufacturers of automobiles in the United States, where Mercedes has recently made $1 billion investment to manufacture electric vehicles. VW has also made similar announcements to manufacture electric vehicles in Tennessee. And now, of course, Tesla has plans to build the Cybertruck and Model Y in Austin, Texas. And what I really love about this map is that it illustrates the fact that, you know, what was kind of traditionally thought of as the heart of fossil fuel country, it's really on the verge of becoming the backbone for the future of America's green energy. And I think it's important, very important to note that the fact that folks on the ground in this region can actually see that green energy jobs translates to jobs for them and their local economy is an incredibly significant development. So going real quick through the challenges to get these projects into production. So vertical integration is key to these projects' success. This means you're essentially having to run a successful mining operation and advanced materials processing company in parallel. If anything, the advanced processing capability is the most critical step for securing these critical mineral supply chains. There's also an accepted standardized methodology for how we de-risk a mining project. But to date, there's been really a major due diligence gap in how we de-risk the downstream. And a lot of times this is because the advanced processing component of these projects is based on new proprietary technology that has never been proven at scale before, at least in the United States. Traditional mining investors don't like that the mining economics are not more attractive in many cases, and that the downstream component is necessary to make these projects kind of sexy to investors. And then the flip side of this is that tech investors don't typically like investing into mining projects. Looking at financing is a major issue. You know, unlike China, the US investors generally lack long-term vision and commitment. Everything is quarter by quarter. So the process from discovery to mining is a long and expensive process. And that's further complicated by having the downstream component attached to the project development. And if you look at just kind of what's happened in the last 10 years, you know, the first wave of exploration activity for a lot of these materials in North America that was initiated by the Tesla Gigafactory announcement in 2012, you know, it's really lacked a poster child of success. Many of the projects that were expected to succeed failed completely or have not rewarded investors. And this is not just with US projects. So it's difficult to properly evaluate these projects in terms of the potential risk and reward, again, due largely to the fact that these markets are very, very opaque and lack these traditional spot markets for the materials that we're kind of more used to. And this goes back to the chicken or the egg problem, where product value is based on securing long-term contracts, and the qualification to be a supplier is not an easy process. The politicization of mining and green energy is also a major issue. So the not in my backyard mentality is very strong in the United States. And due to a few bad actors, US mining has earned a bad reputation over the 20th century as being bad for the environment and human health. You know, these are very politicized topics. Traditional mining in the United States is largely focused on the coal industry, which is mostly viewed clean energy as a threat. The flip side is that most proponents of the Green New Deal are anti-mining. When it comes to environmental regulations, this is really where most of the federal focus has been in the last couple of years. Permitting can certainly delay projects, particularly when you're dealing with mining on federal land. This is not irrelevant, but in my opinion has not been the major hurdle. At least when it comes to the critical battery materials, this has not really held up the major projects to date. So there are a lot of good projects out there that really already have the necessary permits in place to advance, but what they lack is funding. And it's important from the environmental standpoint that we remember that if we're going to have clean energy technology, then we have to have clean input materials. The whole idea is that we're protecting clean air and clean water by adapting this new technology. For the sake of time, I'm going to kind of pass over this really quick, but I can make these slides available to you. This is just a timeline of kind of what's happened in the United States at the federal level over the last couple of years. But I'll point out that this was really all initiated by activities in December 2017. So the United States Geological Survey updated the full critical minerals report for the first time since the late 1970s. And then within 2 weeks of that being published, President Trump issued a critical mineral executive order in support of the building domestic supply chains of critical minerals. And so over the last 3 years, we've seen a number of things take place that have moved us in the direction of building these supply chains, but there's still a lot of work that needs to be done. And I'm happy to elaborate on this in the questions if needed. So what really needs to happen to build out these supply chains? Okay, well, we need to change the way that we think about mining and clean energy. We need to come together politically and really realize that this is an opportunity for all Americans. We also need to place more value on securing sustainable supplies of raw materials. Defense and tech companies should be held responsible for how and where they source their raw materials. We need to look for opportunities to localize and regionalize our most critical supply chains. This ensures the mining and processing is done to the highest ethical and environmental standards. And this also has the potential to greatly lower the overall carbon footprint of these supply chains by simply greatly reducing the transportation distances to get these goods from ground to the consumer. We need US policies to facilitate this transition and encourage that US supply chains of these materials and the manufacturing of these technologies happens. We need to find ways to get the defense industry more involved in developing these supply chains, and also figure out how we can get the oil, gas, and coal industries more involved. You know, they understand resource extraction, they have geologists and engineers, many of which need a pathway that helps them transition beyond fossil fuels. There are a lot of opportunities for federal industrial partnerships and consortiums, you know, around this issue. And we also need to figure out, you know, are there ways that we can get the US government to step up and help solve the chicken or the egg problem? So when necessary, is there potential for the United States federal government to become kind of an off-taker of last resort? And then maybe in addition to having critical mineral stockpiles, which the Department of Defense does manage, maybe we need to also create a national critical mineral reserve. So find a way to place value on these deposits that are still on the ground that allows them to get financed into production. And then last but not least, we just need to find ways to get American money into American projects. You know, the fact is, if you look at most of the projects that have been developed across North America, it's been Canadian companies, Australian companies, and many of those have been financed with Chinese money. So this may require some sort of federal subsidy or tax break. This isn't about allowing technology that's uneconomic and that shouldn't be a long-term, it shouldn't be a long-term solution, but it could help ensure the rapid mass adoption of these technologies and supply chains so we're not left behind. And let's not forget the US government still heavily subsidizes other industries and has for a long time. Here's just some suggested web resources that I made available for anybody that wants some kind of continued learning beyond this talk. And with that, I'm done.
Well, thank you, Jesse. Really appreciate it. And just want to let everybody know and remind everybody that you will be getting an email a few days from now with a link to the recording. And you'll also be able to sign up for the next one. But this will have the resources, and also will have information about the presenters so you can connect with them on LinkedIn. So thank you. And I'm thrilled we have our next presenter, Emily Hersh. And Emily, would you like to share your screen and turn on your camera?
Yeah, absolutely. Hi, everyone.
Welcome.
Thank you. I'm just testing out my new spot for giving presentations. So I apologize if the lights bit off. You can all see me, and I'm going to invest in a lamp shortly because I look a little spooky. Hi, everyone. It's nice to be here. Thank you, Susan and the AAPG, for thinking of me and inviting me. I am going to share my screen, make this full screen, and we will get into.
Great. And as Emily gets ready, Emily's usually in Buenos Aires, Argentina, but she's in the US right now, so it's nice.
Yeah, so I'm actually getting a bit of an error message sharing my screen. So let me give I apologize. It's making me do a permission. So this is unexpected, but I can handle it. Just a second. I am going to, Susan, I have to quit Zoom and jump back on to let it share my screen. Do you want to have the next person go and then I'll go after them?
Okay, that sounds fine.
Okay. I apologize. I will talk to everyone shortly.
No, gremlins abound. So, anyway, great. Well, Tal, Tutmanauer, I want to say that Tal is here, and it's what, 4 a.m., 3 a.m. in Tel Aviv? Absolutely heroic. Yes. Thank you.
Great. So,
Tal is going to talk to us about thermal energy storage. So I want to invite you to share your screen, and as you tell us with Brenmiller Energy, and they have battery technology that's really innovative. They use thermal energy storage.
Yes, hi everyone. So thank you, Susan, for having me. As you said correctly, it is 3:44 a.m. in the morning, and I know Avi Brenmiller was supposed to present, but I have small kids at home, which are usually awake at this hour, so I volunteered to present for you. So just a second, let me share my screen. Okay, can you see it?
Yes, perfect.
Okay. So Brenmiller Energy is a thermal energy storage company. I will just 1 second. Founded in 2012 by Avi Brenmiller. Avi was a former CEO of an Israeli thermal solar company called Solel, which did thermal solar plants in the US and in Spain, several hundreds of megawatts of them. In 2009, he sold his company to Siemens and started in 2012 this company, which focuses on thermal energy storage. We have invested, as for today, over $70 million in the company. And we are located in Israel, where we have our office and manufacturing plant, and we have projects in the US, in Italy and Brazil, and also, of course, here in Israel. I will skip this slide. I will just jump right into the technology of the company. So as I said, we are a thermal energy storage. We store heat in the form of high temperatures in hot rocks, in a crushed rock media, which is a type of a volcanic stone, which we crush and compress into these types of modules that you see here. These modules are manufacturing in the manufacturing plant here in Israel, and are shipped globally to be assembled in the projects that we do. These modules not only have the capability of the thermal storage, but they do the heat exchanging and the steam generation inside the same design. These are high temperature storage. They go up to 750 degrees C, which I can't translate to Fahrenheit at this hour in the morning, but I'm sure some of you can help me with this. This is a green technology. Unlike other technology, this has no chemicals or salts or any hazardous materials. Nothing could explode. It is modular. We can start with single megawatt hours of thermal capacity and go up to hundreds of megawatts. This is a very long lifetime. There is no degradation of the materials. Very simple O&M, unlimited cycling, and this is a hybrid solution. As I will show in a minute, this solution, this thermal storage, could be charged with several sources, either with a heat source, whether it's thermal solar or an exhaust of an engine or a turbine or a biomass source, or could be charged with any type of electricity, either a renewable source like PV or wind, or off-grid or a low tariff electricity from the grid. We store this heat, as I said, at high temperatures. If we get electricity, then we have embedded electrical heaters inside, which convert the electricity into heat. And on the output, we deliver steam. This steam could be used for power generation. It could go up to 100 bars to generate electricity with a steam turbine, or could be used as steam at 10 bars for industrial purposes, or at lower pressure for hot water, for district heating, or for any type of application for hot water. So these in between these multiple sources and multiple outputs, we can deliver several types of applications to use this product. So this is how it looks. We have two types of products. One is larger for the utility scale. These are 12-meter modules, which are 40-foot containers. They go to a utility scale projects, tens or hundreds of megawatt hours, and deliver steam all the way up to power production conditions, superheated steam. And we have an industrial smaller scale. These are 20-foot containers. They go to a single megawatt hour storage capacity, which will usually deliver an industrial conditioned steam or hot water. These are operated unmanned and remotely controlled. So unlike other boilers or pressured orientized products, this is something that is relatively simple to operate and low cost O&M. I will just say that, for this slide that as a company today, we focus on the industrial heat market, which is very heavily based today on fossil fuels. You can see on the right-hand side, the amount of energy which is being used for the industrial heat market, and we think this niche is very heavily based on fossil fuels, and we want to address this and with this thermal storage help more and more renewables penetrate the space. As I said, we are located in Israel, but we work with several partners globally, in Brazil, in the US with the New York Power Authority, in Europe with Enel, and here in Israel. I will just review some of the products and applications that we have today. So this first product is a biomass-based thermal energy storage, which is charged with wood pellets, which is a very cheap and considered renewable source in Brazil. We store the heat coming from this biomass in our storage, and we deliver hot air to an industrial customer, to a plastic factory in Brazil. You can see the ROI, which is delivered in this project. Here in Israel, we have a project with the Israel Defense Force in an off-grid base, where we collect the heat from a diesel genset, which was like an open cycle, which was the flue gas was being evaporated into atmosphere. So now we collect this heat, and then we store it, and we deliver hot water to this military base. You can also see the return on investment on this project. In the New York Power Authority, which is a partner of us in the US, we are constructing at the moment a project in New York in University campus in SUNY, which is where we install a micro turbine, 250K gas turbine, which delivers electricity to this campus. And we collect the residual heat from this exhaust. We collect it, we store it in our thermal storage, and we deliver hot water according to the demand of this university campus. Converting this type of open cycle application to a closed cycle and having a dramatic amount of fuel reduction and emission reduction. So this is being constructed and will be delivered, commissioned by the end of the year. We have projects in the utility scale. This is one in Israel with a 75 megawatt hour of thermal storage connected to a CSP plant, to a thermal solar plant. This 5 megawatt hour solar field is connected with a very large thermal storage, which collects the thermal oil from the solar field. It has a capability of 16 hours of storage capacity and is connected to a steam turbine and delivers electricity to the Israeli grid with a 20-year PPA. And another project we have with Enel, the Italian utility, is in a combined cycle in Florence, Italy. This 23 megawatt hour of thermal storage is connected in between the gas turbine and the steam turbine in this combined cycle, allowing shifting of steam, shifting of thermal energy from low value during noon when there's high renewable penetration and lower tariffs to this power plant, and shifting it to the afternoon and to the evening time, to the evening peak, to deliver high value energy. So doing this shifting of energy not only brings value higher value to the energy, but it allows higher maximum load and lower minimum load to this power plant, and some other ancillary services which translate to some new revenue streams. So this project is under construction and will be commissioned in Q1 2021. This is what I have to show you here. Susan, I don't know if you.
That's great. Well, thank you. Yeah, thank you. I really appreciate it, and this is extremely interesting. I'm sure that people will ask. People have asked if you will share your slides, and we have a few questions that we'll save till the end as well.
Definitely.
Great. Well, thank you, and glad to see that Emily Hersh was able to log back on. And so I'd like to invite her to share her screen and make a presentation. So
yeah, okay. Hi, it's not letting me enable my video.
Oh yes, I think
I'm not able to.
You have to stop sharing the screen. Mine? Yeah. Perfect.
All right. It's saying the host disabled attendee screen sharing.
Oh, okay. When you log back on, I thought I'd made you. Okay, I'll have to just go ahead and
Okay.
make you a co-host again. Sorry about that.
Oh, good.
Good. Okay, great.
All right. I was thinking this was a judgment of my my homemade face lamp that I've made, but I'm glad that it's appreciated. So here we go. I think everybody can see this now.
Looks
Are we?
great.
Okay. So hi everyone. Just to kind of give you a little introduction, my name is Emily Hersh. I am a business owner. I do quite a bit of work in the lithium market. I work with clients from early stage exploration through getting lithium physically into battery materials. So I have the experience working with the most early stage kick in the rocks geologists all the way to technology companies that are considering new and innovative ways to make battery materials. So I am not a geologist, and I probably lack some of the technical background that a lot of the attendees may have. So I apologize in advance if some of my explanations are pedantic. So the lithium market gets a lot of news, gets a lot of attention, but it is confusing and has a lot of moving parts. So what I've done today is try to put together a presentation that kind of goes over what are the key areas to pay attention to in order to understand what's the potential opportunity and what is probably not. There we go. So when you look at the lithium industry, there's a lot of kind of forces that are working in parallel. And to understand which way and which direction things are going to go, it's important to understand cathode chemistry. What type of lithium chemicals are going to be demanded? Are people going to adopt EVs? And if so, to what scale and to what extent? Overall economic health, GDP growth, and other consumer spending trends are linked to adoption of EVs as well as other battery materials. Lack of capital investment. The lithium industry suffers from a chronic undersupply of investment. Extraction technology. What kinds of technologies will be used to get the lithium out of the ground and into the batteries? Issues of social and environmental license, especially questions of water use and the impact on indigenous groups. Trends of deglobalization in the supply chains. Will national security and low carbon drives cause investors or projects that are in sort of local ecosystems or local bubbles to be preferred? And then government incentives. What are governments doing to either subsidize EVs or put in place emission standards that promote a transition to EVs? So there's a lot going on. Right now with the COVID-19 crisis and how that is coming forward, there's really three areas that are more important or that need to have more attention paid to them. And one is there going to be a recession? How deep is that recession and what's going to happen? Mostly because unemployed people don't buy cars. And the biggest driver of the lithium market is batteries for electric vehicles. But then on the other side, you've got supply chain localization and government action. And so when you're trying to understand the timing of when these opportunities in the lithium space will come together, you really have to look at it kind of like this. I personally think that the recession is still outweighing the forces of supply chain localization and government action, but I think that we are shifting and making a shift to the other side. But as long as the economy is marked by uncertainty, high unemployment, and more than anything, volatility, there will be pressure on lithium companies and lithium producers for cash flow, simply because the demand for the product will materialize later. So now that we've got that out of the way, let's talk about why everybody is so excited about lithium in the first place. I hope everybody has seen graphs like this, that the demand for lithium chemicals is rising so quickly and slated to or predicted to rise almost in an unprecedented manner to any other commodity in the history of modern markets between now and 2035. And if you look at this chart here, you'll see that along the sort of the short term or between now and 2025, you have a situation where demand could be higher than supply. But very quickly, we get into an area where even if all of the projects that have been planned and are currently known to, or all of the deposits that are currently part of companies that are actively developing them, we still have a shortfall in supply. And so this triangle here is interesting and exciting to business people and people in the mining and the minerals extraction space, because it means the world needs more lithium and the current incumbent suppliers cannot possibly hope to get this here. So now that we're all excited, let's have a little bit of a reality check. This is my favorite graph to talk to investors about lithium, because I think it really explains how there's a lot of excitement, but then little action. And it's because you can see here that this is the dollar size of the lithium. This is the size of the lithium market in US dollar terms, rising from 2015, 2017, and 2019. And you can see that this bubble triples in 2 years, and it just keeps growing. And if you consider that the market is going to keep going like this, you can very, very realistically say, okay, maybe it's this year, maybe it's next year, maybe it's the following year, but this is going to be a pretty big gray circle, great investment opportunity for me. But then you talk to people who have done gold investments, and you put this little dot on top of the gold market, and all of a sudden that rising, that size or that growing size of that silver dot isn't such an exciting investment prospect. And the idea of having the growth put off by a few years gets scary. And I hope we've got some oil and gas folks in the audience, because this is the one that's the real kicker. This is that little dot on top of the oil market. And as you can see, it almost disappears. And so when you're trying to consider an investment or trying to talk to a company about developing a lithium asset, you'll very quickly get comments like, why would I care? The entire market is the size of the production of one of our wells in Ecuador. So when you take a look at the market from an individual company perspective, it's easy to understand why individual players, especially in the oil and gas space or other mining spaces, are reticent to jump headfirst into lithium, because the market is small, it is volatile, and it is complicated. So now let's get into a little bit more technical work. This is kind of the lithium market is a baby. Lithium markets are in their infancy. And so when we go into lithium, we have to understand that there is tremendous potential. The market is growing very quickly, and there are many spaces, not only for technological innovation, but understanding how deposits behave and understanding ways to unlock new deposits. That being said, there is not the type of sort of copy paste or a wide range of successful projects from which you can draw to say, here's my lithium asset, this is how I'm going to develop it. Now we're going to get into a bit of the technical nature. So the first question that most people ask is, what does a lithium deposit look like? And the answer is, it depends. Now, lithium is very easy to find. It's an element that is relatively, it's not scarce on the Earth's crust. It's a relatively abundant element, but it's difficult and expensive to commercially extract lithium in a way that you can get it into a battery. So here is kind of just an overview of lithium deposits. You've got your conventional brines, which is the famous lithium triangle, where lithium-bearing brines are pumped from underneath salars or salt flats in northwest Argentina, northeast Chile. And there are large deposits in Bolivia, but they are not currently being commercially extracted. And then you've got hard rock spodumene deposits, which are what you have commercially being extracted from Australia, but then sent to China to be processed, similarly to the graphite example that Jesse used in his presentation. And then you've got these deposits in red that are known lithium deposits, but we don't currently have commercial extraction of lithium from this type of deposit, from these types of deposits. to go into batteries. So in Nevada, we've got a couple very interesting clay deposits. There's an oil field brine deposit in Arkansas, and I believe other oil field brine deposits that are of interest in the Southeast. You've got geothermal brines, which actually this is a picture of a geothermal brine, but it was more symmetrical to just put those brines together. And geothermal brines are the famous Salton Sea and the deposits in California that you might have seen some media buzz from the Berkshire Hathaway camps talking about developing. You've got lepidolites, which look like this. You've got clays. You've got volcanic tuff, like is in Peru, and I've actually got a chunk of it downstairs I was going to bring, but it looks like a heavy cement almost. And so what I'm saying from a geological standpoint is lithium deposits all look very different, and the process by which you would get the lithium from how it is presented naturally into a commercial lithium compound depends just as much as the deposit type. So it's important to understand that the very element of lithium, or the very characteristic of lithium that makes it an excellent battery, is what makes it such a pain in the ass to work with. Lithium never occurs freely, it only occurs in combination. So it occurs as part of chemical compounds. So what that means is that lithium chemicals are actually not a commodity. So words like refining and purifying don't really work for lithium, because what you're essentially doing is you're trying to get the lithium atom off of whatever chemical combination it's perfectly comfortable with in nature, which it does not want to do, and get it into another chemical combination that's going to be used in another chemical process to get that lithium ion into a battery cathode. And so when we talk about lithium, it's important to understand what we're talking about when we're trying to compare different projects or compare different processes. I put this in here so that it's understanding that from a lithium standpoint, you've got a mineral extraction process, then you've got a chemical process more than a refining process, then you go to cathode production, cell production, module assembly, and an OEM. So the lithium ion battery value chain has a lot of different steps, and each of the steps requires, actually, you know what, I'm going to skip this slide because y'all know this and it is overly simplified. This table takes a look at the concept of lithium carbonate equivalents. So its table shows you physically contained lithium within different materials, but this is to illustrate very clearly that the price of a lithium chemical doesn't depend on how much lithium it contains. And a very easy one to look at is lithium carbonate versus lithium hydroxide. As you can see, there is more lithium metal contained in lithium carbonate than lithium hydroxide, whereas we're in a pricing situation currently where lithium hydroxide prices are in general much higher than lithium carbonate prices. And that's because the chemical combination of the lithium in the hydroxide allows the reaction to make a cathode to occur at the lower temperature that having a high nickel cathode requires. So the price of a lithium compound is not like gold, it's not like copper, where you take the weight of the commodity multiplied by some kind of purity formula and you get a lithium price. Lithium chemicals are priced by what kind of chemicals the market needs for a certain process, which is changing as battery chemistries change, and also the purity of not just the contained lithium, but the on a sort of on a molecular level, the different other characteristics and what other impurities the lithium chemical contains. And you can see this pretty clearly in the slide I'm about to show you. This is an example of lithium carbonate, same month, same physical destinations, sold by two companies across the Andes from each other. One is one is Oro Cobre, which is an Australian company in Argentina, and the other is SQM, which is a lithium company in Chile. And you can see that for the same product, same percent lithium, one was selling for $8,000 a ton, and the other was selling for 12.5. We are now in a pricing situation where this 12,500 dollar per ton product is selling around around 10 to 11, and this off-spec product is selling around 4,000 or 5,000. So when we talk about value added and we talk about what makes a good project versus a project that's not investable, knowing what kind of quality a deposit or a project is going to be able to produce is much more difficult than with commodities that are not in such an infant stage and in their infancy. And so when we try to take lessons from other markets and other commodities and apply them to lithium, we run into areas that are difficult to navigate. And so a good lithium project depends. And it really is important to understand and not just try to take something that's worked in oil and gas and apply it to the lithium market. So going back to this kind of battle, you'll see a lot of news and a lot of media talking about what lithium is best, whether we want lithium carbonate or lithium hydroxide, if a project should produce lithium carbonate or lithium hydroxide. And quite honestly, it depends. And the advice that I give is don't prepare to fight the last war. Just because right now, high nickel cathodes are helping solve the range anxiety to get electric vehicles to performance parity with ICE vehicles. And just because you're seeing the move away from cobalt push automakers to want a lower high nickel cathode, that doesn't mean that that trend is going to continue. And new cathode technologies, new anode technologies, and new battery technologies are one of the areas where you see a high degree of investment in research and development and a high degree of competition to make a better battery. And the lithium market will respond to that demand and not the other way around, i.e., you won't see lithium battery makers choosing to make a battery because they have better access to carbonate or hydroxide. They will make the battery that makes the EV consumers happy, and the lithium market will fall in line. One of the more interesting areas to look at with lithium extraction or lithium chemical production is that there is a lot of technology that's coming into play. This is an example of direct lithium extraction technology that's worth taking a look at, where you can see a lot of areas where technical experience in oil and gas and technical experience working with other brines might be able to bring solutions that can solve, for example, the water consumption problem inherent with some of the extraction methods that are not efficient, or in areas where access to fresh water is challenging. So it's interesting to see how, because lithium is such a nascent industry, many trial and error processes that have been utilized in other industries have a lot of opportunities to come together and find strategic combinations and unlock value in resources that simply haven't had those skill sets brought together. So I think that success in the lithium industry will require the taking down or dismantling of some of the siloed thinking of especially big companies that have done things the same way for the past 50 years, breaking down or dismantling barriers between technical teams and technical processes, and looking at finding a new angle to take on problems that solve or make irrelevant some of the issues that we have, like water consumption, energy consumption, etc. And so that's the end of the presentation. I can take any questions that anyone has about the lithium space or go into more detail. I do a podcast. It's called the Minerals Manhattan Project. You can find it at mineralsmanhattanproject.com. You can follow me on Twitter at Lithium Podcast. And again, thank you for having me. If there are areas that this group has interest in learning more on lithium, I would be happy to go do some homework and bring it back. But that's the kind of the overview, and I hope covers the areas that if there's one of those little points on the wheel that you're interested in, it's worth deep diving in and getting involved. It's a complex but really exciting place to be.
Well, that's great. Well, thank you, Emily. That was wonderful. What wonderful presentations. So what I'd like to do now is to invite everyone, the presenters to, okay, you might stop sharing your screen, and then I'll
Sorry.
invite no problem. I'll invite the presenters to turn on their cameras and open their mics, and we will, okay, Kastle, and let's see who else. And Jesse, you want to turn on your mic and,
I'm here.
okay. Great, thanks, Kastle. Excellent. Great, Jesse, oh, well, if you don't want to turn on your camera, we won't force you. But anyway, so I thought we could just chat a little bit. We have a few questions from the audience. And I think, let's see, one of the questions is what is actually what is the heat storage for the batteries for the large scale?
The heat storage is based on a type of a volcanic rock. I'm not sure if this was the question was intended to what type of media, but the medium is a volcanic crushed rock, which we compress into types of models that I saw you before, and they have very good capabilities of storing and transferring the heat. And this is also part of the IP of the company.
That's great. Okay, so I have a question for Emily, and this is from Patrick Ing. And Emily, do you consider lithium as a mineral asset or an energy transition hedge?
Mineral asset. I mean, I don't think people should invest in lithium. And again, I'm taking hedge in the in the sort of investment space. Lithium assets are so different between each other that it really makes sense to take good assets and try to do flexible things with them but I wouldn't try to hedge something by being invested in lithium.
Okay, that's an interesting question or answer. Kastle, here's a question that we had from Edith. And Edith, if you want to ask it with your, open up your mic and ask it, you can. But Edith is basically asking if it seems like it makes sense for Oklahoma to, Edith, do you want to ask it or do you want me to read it?
Oh, I'm fine to come on board and ask it. And actually, Kastle and I have already connected on LinkedIn, and we will be talking in the future, so no problem there. But I'm just interested in the fact that that the Tulsa Innovation Lab seems to be pushing efficiency technology around fossil fuels when you know, on Jesse's map, for example, Oklahoma is kind of this blank space for battery tech, the supply chain associated with critical minerals mining, processing, and battery tech. And I know for a fact in Tulsa, there are many innovative battery tech companies that are springing up. So I was just curious about that intersection.
Yeah, and it was a really good flag. So I mentioned kind of that the oil and gas tech, the efficiency play, I think in terms of Tulsa Innovation Lab's grand strategy, that's much more of the short-term vision. So there's definitely an opportunity to shift our local oil and gas companies more towards tech-driven companies being able to leverage their data. And so we want to allow some room for that space to develop. And you know that opportunity is here in the next 5 to 10 years, and so that's kind of the looking for the big wins. But you're absolutely right that there are many more opportunities in thinking, you know, long term, and especially in terms of sustainability, things like battery tech and renewable energies and alternative fuels. I think those are the innovations that we're actually even more interested in. So we want to start once we have next year doors open for an accelerator program and a fund. Anticipate that that'll be maybe a majority of the activity for the startups that we're trying to attract and fund. And in particular, you know, we work closely with a lot of the corporates here, and even on the oil and gas side, we see that they're starting to look for ways to diversify, you know, their own assets and position themselves to be kind of the leaders for, you know, industries that they wouldn't have thought that they would have been in before. For example, Williams, again, are now operating a lot of their natural gas sites with solar panels, and are really interested in investing in that space. A lot of the local corporates now are talking about, you know, really looking for ways to diversify their own portfolios. And I think the things that you mentioned are really interesting, in the fact that there are a lot of kind of innovative battery tech spots popping up around Tulsa is something we definitely want to leverage and take advantage of. And, you know, I'll just say one more time, we're still kind of in the ideation phase. So, you know, connecting to these people and finding out what's actually here that we can leverage is exactly where we're at right now, and hope to take advantage of that and set up our programs so that, you know, we position ourselves not just for this oil and gas tech in the short term, but the sustainable solutions as well.
Great. Well, I look forward to talking with you further. And I think there's a huge opportunity on the midstream side for the hydrogen economy. And let's have that chat. Yeah.
That's great.
Yeah, I'd love to.
Thanks, Kastle.
Yeah, thanks. Thanks, Edith, too. Okay, so 2 questions for Jesse Edmondson. It's from Peter Michael. Is the heavy rare earth resource at Round Top Mountain in Texas sufficient for our country's needs in case international sources were disrupted? And are there other heavy rare earth resources in the US that are more economical?
Right, so interesting question. I'm not a big fan of Round Top Mountain because of how low grade it is. It's a project that's been around for a long time. Depending upon what year it was, you know, that mine was a potential source of, you know, essentially every critical mineral on the list. So, you know, it's been well promoted. I will say that there is a dedicated team behind it. And so, you know, they are dedicated to moving the project forward. They do have some political support, but looking at it purely from trying to be an objective and and looking on the technical merits, it's just, I don't see how it would ever work. The required CapEx and OpEx would just be so kind of outrageous that I don't really see that coming online. I think now, as far as the heavy, so just for the greater audience, it's important to point out, so you hear the word rare earth elements a lot. And in fact, it's quite common that the word rare earth elements and critical minerals actually get mistakenly used when they're not really synonyms. So rare earths are a critical mineral, but rare earths are actually referring to the lanthanide series on the periodic table. So you're actually looking at 17 different unique elements. Again, to make those technology ready, you've got to be able to separate them into distinct, you know, unique elements, each of which has unique chemical properties that are utilized in technology. And really where most of the demand is for the magnetic rare earths. And so that's actually right in the middle. It's kind of the end of the light rare earths and the beginning of the heavies. But that's really what's in demand for, you know, wind turbine generators, for the permanent magnets and electric vehicle motors and all these kinds of things. So that's really the most, I think, the most important component of the rare earth supply chain to shore up. And so if you're looking at US sources of those rare earths, my opinion is that monazite is actually the solution. And that where I think the most economic short-term options for that is for if you referring back to my slide of the Southeast, that company Chemours, because they're able to produce a monazite sand as a byproduct. So they're already making tons of money mining titanium dioxide and zircon sand. And now they've realized that they can separate out that monazite component and sell that separately. To date, they've been selling it to China. You know, unofficially, they're making moves to make sure that they're not shipping it to China anymore to be processed. So I think that's kind of, I think, the best solution for the US rare earth supply chain.
That's interesting. People probably don't know that the US has a synthetic rutile plant. Speaking of titanium dioxide, and it's made from ilmenite. Anyway, It's in Mobile, Alabama. So anyway, so we have a question for Tal Tutmeier, and this will be our last question for the evening. So Tal, what is the maximum cycle time for thermal storage to still be efficient? Can it be stored for several days?
Yes, this is an economic question. The heat loss on our thermal storage is approximately 3% per day. So storing the heat it's basically designed for daily cycling, but it could be stored for over the weekend or for several days after. Storing it for weeks or type of seasonal storing is not an economic application for it, as you will not have any energy left in the storage. So basically it's for daily cycling or over the weekend.
That's great. Okay, so we do have 1 or 2 minutes left. So John McLeod asks, you can read it in his questions and answers, but I'm just going to jump to any ideas about what energy storage might look like in 10 years. Anybody want to jump in that one?
Sure. Well, I mean, as far as battery technology goes, and Emily and anybody else can certainly jump in, but the guys at Benchmark Minerals would point out when you're talking about what the future of battery technology is going to look like is follow the money. And so right now there's being billions of dollars put into building these large lithium ion battery plants. Lithium ion batteries were, created or invented in the early 80s, but they just now really become fully commercialized. And even if you just look at the last 10 years, the amount of technology development and improvements in the performance of these batteries is just, it's going up, significantly every year. And so there's going to be little things that can be done on the anode side and the cathode side of these lithium ion batteries to get better performance out of them. And so I think in the next 10 years, it's still going to be dominated by lithium ion batteries. But, the part of this question that he mentioned, lead acid, it's important to point out that lead acid's been around for 150 years. But if you still look at the entire energy storage market as a whole, it still has the majority of the market share. So these things take time to develop. Absolutely, solid state batteries are going to come online. I mean, they already are to some extent, but it's kind of a niche technology. But as the safety the safety gets worked out with that technology, and as there become continued improvements in the manufacturing and bringing the price down. I mean, price is going to be one of the major dictators, of course, for these kind of shifts in adoption as technology goes forward over the next decade.
I'll I think that I tried to answer the question with typing and failed that technology battle. So lithium, the solid state is a lithium battery. It's not a lithium ion battery, but when you look at lithium demand, you will be having lithium demand to make a solid lithium anode. And the amount of lithium chemicals or precursors that are needed to go into that process are different than what the market looks like now, but the need for lithium is the same. I don't think that you're going to see as many, or it would surprise me if the dominant storage for sort of grid storage or large scale storage ended up being lithium ion. Unless it's reused lithium ion batteries from cars, i.e. they're already there, and yes, they're no longer good enough to power a car, you could still cover 10, 15, 20 minutes of, essentially get rid of the spinning reserve problem, etc. But when it comes to shifting renewable energy production to cover sort of nights, shortfalls, etc., my experience with finding ways to store large amounts of energy for that long of a period of time, it would be, I think we'll see some kind of a flow battery of some sort. I don't love vanadium, but there are flow battery technologies that I find interesting, or some kind of a physical storage kind of similar to what I believe that Tal presented. I just can't see the numbers that I ran up, and those massive increases in demand for lithium. I only use passenger EVs on those, and anything else to me is kind of icing on the cake. And if you looked at trying to increase that demand to cover grid storage or large scale storage, I think your other inputs like cobalt, for example, and battery grade nickel would run into more challenges than the lithium market to try to supply that. I could be wrong. I know very smart people who have very strong opinions on the other side, but my gut is that we're going to see other solutions for large scale and grid storage.
That's great, Emily. That's very interesting. So, okay, we have 3 more questions, but I don't think we have time. So I'm going to ask something kind of bold. Okay, so I'm going to ask the people that these questions are directed to answer the questions in a little post in LinkedIn, and say, like, put a post there, or I'll put the questions to you in LinkedIn, and maybe we can go to your LinkedIn page and answer them. But first of all, Tal, how would you transfer wind power to your module? So I'll ask you that question in your LinkedIn, and you can answer it if you want to. And then Marlon Griggs has a question. How would you recommend beginners get started with learning about and investing in lithium? So I'll ask that to you, Emily, and also to you, Jesse, in your LinkedIn. We'll see if you don't mind. And then Jim asks, we've talked about lithium, but are there multi-element possibilities, or the refining can only focus on a single element? Who would like to tackle that one?
It's using the word refining misses the advanced processing-ness, and life, like lithium, is about trade-offs. So you do, whether lithium is your primary product, most of the lithium that's produced in Latin America began as a byproduct of the borates industry and of fertilizers. So you do extract other elements from your raw material, but get away from use of the term refining if you want to understand critical minerals and the value added step of the advanced processing.
Excellent. Thanks for that, Emily. So basically, I want to really thank you. So thank you, Kastle. Thank you, Jesse, Emily, and Tal, and really appreciate everything. Also, Larry Davis is not with us tonight. He's in Texarkana, and they're battening down for Hurricane Laura, so he was not able to be here tonight. So our thoughts are with him. And I'll be sending an email with a link to the recording, and also a link to next week's series, our program. And just want to thank everybody again. So have a nice evening. And if you're in Houston or in Texas or Louisiana, Arkansas, take care. Night.
I really enjoyed this. It was a lot of fun. I actually found out about it from your financial literacy class. So it was very new for me. It was very interesting.
Oh, good. Great. Thank you.